My name is Yuri Takteev. I'm the CTO of Rengaleo. We are a JavaScript development shop in Toronto, so we focus on JavaScript. And what I wanted to talk today about is handling the deeper parts of your front-end JavaScript stack. Now, oftentimes, I think a lot of developers today, they're asking Angular or React, right? This is probably the most common option. People come to us oftentimes asking, we're about to start building the new app, and what shall we do? Shall we build it in Angular? Shall we build it in React? Obviously, some people still are thinking in terms of other frameworks, but those are the two dominant ones. Now, and what I want to talk about today is that really, ultimately, it's not really the choice about Angular or React that matters most for your application. What matters most is how are you going to actually handle complexity deeper down in your stack. So let's talk a little bit. I mean, what are we actually after? Why are we even sort of discussing? When we care about choosing one framework or the other, what's at stake? And what's at stake is ultimately taming complexity, right? So I mean, if you're building a really simple application, it sort of doesn't matter what you use. You could build it with jQuery and it's going to be fine, right? I mean, unless you're talking about mobile and performance. But generally speaking, it's not going to be that complicated. But as your application gets more and more complicated, and especially as you get towards more of a kind of enterprise scale applications, what ends up getting at you finally is the complexity, where your application becomes so complicated that really you have no idea what's going on, right? So a typical complex SPA single-page application today looks roughly like this, right? You have lots of parts. Everything is somehow connected to everything else because you start off thinking that it's going to be all neatly compartmentalized, but eventually it turns out that everything needs to talk to everything else. And as a result, changing anything somewhere ends up breaking something somewhere else, right? So and this is where increasing the scope of your application becomes increasingly difficult. And I think the important thing to keep in mind is that this mess can be achieved with any framework, right? You could build an application like that with Angular. You can build a mess like that with React. Not to mention, of course, you can easily build a mess like that with any of the earlier frameworks. So what are sort of the best known solutions for this as of end of 2015? So as far as I can say, there's two main things that everyone needs to be focused on. One is component-based UI. So you want to build your application in terms of components. And I will talk a little bit about what that means and how you could achieve that with Angular versus React. And then the second approach, which I think is the bigger part of the solution, is taking what I'm going to call the stateless approach towards architecture deeper down in your stack. So let's first say a few words about component-based architecture. So the idea is that you want to build your UI layer application. Notice that I'm talking here just about the UI layer, the stuff that the user sees and that they actually interact with. And I will talk later about the fact that you want to make your UI layer as thin as possible, so it shouldn't be, we're not talking about all of your application, we're just talking about the thin facade that the user interacts with. So that facade you want to build as a collection of UI components that have well-defined interfaces where it's really well understood and limited interfaces in terms of what talks to what. And you want most of your components to be agnostic of the application. You want them to have no idea what kind of application they are part of, whether your application is about ordering tickets, or whether your application is about tracking orders, or whether your application is about launching nuclear missiles. It shouldn't matter, right? I mean, they should be, your components should have a very well-defined, purely UI purpose. And this really helps with code reuse. That's one really big advantage of this. This really helps with testing because you can actually test your component each component in isolation from the rest of the application. That makes it really, really easy for you to actually, refactor the rest of the application separately and refactor the component separately. It also makes it a lot easier to reason about your code. And I mean, you will hear me using that word a few times. I mean, ease of reasoning. This is really important. As you want to deal with more complex applications, you want to build them in such a way that you can actually understand what you've done there. Now, in order to think, when you're thinking about components, it really helps to think about a typology of components. And here I'm stealing from other sources on the web, as if you're familiar with this topic. And the way to think about the different types of components is to think of them in terms of dumb components. And dumb components are components that are not aware of your application at all, right? So an example would be a button that just makes a click. It doesn't really know what that click means. A date picker, a menu selector, those kind of things. You also have smart components. Smart components are hooked into the rest of your application. So they are tied to your business logic. You do need to have such components. And then finally, we'll talk a little bit about smartish components. That's the term that we've come up with at Wrangle. And this is components that's sort of in between. And I'll talk about why it makes sense to have some things that are a little bit in between. So a typical dumb component looks like that. So it's contained inside the parent. So it belongs to another component. And it interacts only with that component. So it accepts information from the parent through property changes, and it basically signals information out either by posting events or by changing its own properties, right? And you kind of want to, generally speaking, shift towards posting events. So an example of this would be a button, right? So I mean, a button basically generates an on-click event. That's really all it does. So I mean, a typical like built-in UI button really has no idea what it's for, other than the fact that you can the parent attaches a callback to it, it gets notified when the button gets clicked. So this is an approach that you want to use to somewhat more complex components in your application. They should still be just about as dumb as a button. So you want to maximize, in order to tame complexity in your application, you really want to maximize your dumb components. You want to think of everything, every component, you should look at it and say, can this be done as a dumb component that really does not know what it's for, and you should consider doing this. Now, in contrast, you have smart components that do actually need to, ultimately, they need to communicate with the business logic of your application. And I will talk a little bit more about the architecture, but the preferred approach there is that they will actually send action events to the rest of your applications, and they will listen to events coming from your applications. And I'll talk a bit more about the importance of this sort of unidirectional data flow, where they don't have access to a state of something else in your business logic. They actually send events and they receive events. And finally, and so you want to use those sparingly. It's really important to use them sparingly because you cannot trivially refactor UI components separately from your business logic and vice versa, and that's where you want to actually that's why you want to minimize their use. Now, you also, in many cases, in particular with the architecture choices I'll talk about, it often makes sense to have components that are sort of fit in between, where they do not actually ever watch anything inside of your applications, but they do emit events directly. The advantage of this is that compared to dumb components, you actually end up saving yourself quite a bit of wiring and boilerplate, while you actually capture most of the reduction of complexity. So in this case, we're talking about an event that sends a particular event. So when you basically instantiate, you just say that when this button gets clicked, this is the event it sends out. But at the same time, it will not be actually paying attention to anything other than what the parent actually sends in. Now, an interesting thing about components is, just worth to, when it comes to choice between Angular and React, is to consider that in Angular, we've had components all along in the form of isolated directives. I mean, they were always there. They sort of never really were quite loved. I mean, I think the Angular community started coming around to them recently, but there was a lot of sort of like, we don't really know why we have directives up until recently. Now, in contrast, React community has really brought components into the limelight. Like with React, with React, everything is component-based. And I think what's important is that the React community have actually also really done a lot of thinking about how components are organized, and the sort of the typology of components that I was just presenting, that comes out of the React world, as well as a lot of the other architecture choices. So the React community has really helped clarify our thinking about components, and from that point of view, anyone who is working with Angular today really owes it to themselves to pay attention to what is happening with React, and you really would be a much better Angular developer if you understand how React works. Now, that said, you can have components in Angular 1. And so in particular, one approach that I would recommend to everyone who is working with Angular is read React documentation, understand how components work in React, then come back to Angular and just do the same thing. I mean, you really can actually follow that approach. I mean, with React, you sort of don't have a choice. But with Angular, that approach is still open to you. And then also it's worth noting that Angular 2 is actually now really putting components at the forefront. I mean, in Angular 2, like in React, is going to be all components, components, components. So in that sense, we expect that the Angular community will have to go that way anyway. So I mean, the bottom line there is that if you're working with Angular 1, you really should be starting thinking about components now. If you're working with React, then chances are you already are. Good for you. Now, So all of this, however, is in the UI layer of your application. And if you want to tame the complexity in your application, you really want to find yourself in a situation where the UI layer is as thin as possible, where there's really not that much to it. So what about the rest of your application, right? And so there, I think the way you tame complexity is by thinking in terms of what I'm going to call stateless architecture. So let me talk a little bit about why stateless is a good thing. So a lot of us were raised on object-oriented programming, and we still sort of find ourselves thinking in terms of object-oriented programming. And it's fair to say that a lot of Angular 1 thinking is really very object-oriented in its base. And objects are fundamentally stateful, right? So, I mean, which is to say that you have this black box that you basically push buttons on, that you call methods, and every time you call a method, something changes inside, right? So it has state inside. And the next time you call a method, what happens sort of depends on what methods you called earlier, right? So if you actually called a setName method then earlier, then now when you call getName, you'll get a different name, right? So this is essentially, the effect of calling a method on a component depends both on the arguments that you pass to the methods and to the internal state of the object that is actually by design hidden from you, right? So you can only sort of guess what it is based on the sequence of methods you've called earlier. So there's a few downsides to this. I mean, one of them is that it's really, really difficult to test, right? Because the behavior of every method really depends on the whole history of events. So you can't really actually set clear expectations of what the result of calling a method ought to be. That is to say, what would be the correct behavior, because in many ways the object itself defines internally what's the correct behavior. Second is that it's actually also very hard to understand. It seems easy on the surface, but in practice, what you have to deal with is that you really never quite know what to expect after calling any given method. Now, and it's worth thinking of why, I mean, if it's so complicated, if it doesn't help any problems, why did this ever get to be so popular? I mean, I think the answer is because when object-oriented programming was introduced, especially in its sort of Java style, the promise was that it's going to mimic the real world, right? That you have this, like, student is an instance of a person, right? And the truth is, when we actually work with data, data is different from real objects in the real world. And you just end up by trying to create this very kind of dumb parallel between the real world, between real kind of is a instance of relationship in the real world and our data model. You end up reproducing a lot of unnecessary complexity. And the question is, why do that? So in contrast, so what's the alternative? Well, I mean, the number one alternative is functional programming, and in particular, the idea of a pure function. So a pure function is a function whose output depends solely on inputs. So whatever you pass fully determines the output, right? What's nice about this? Well, and pure functions also would have no side effects. So they basically don't do anything. They just give you a result. You call a function, you pass in some inputs, you get back some output. Why is that exciting? Well, and what this also implies is that they actually have no state, right? So in the sense that it doesn't matter whether you've called it before, right? When I call the function now, the result it returns depends on what I pass in right now. Whether this function was called before, whether other functions were called before, it absolutely is irrelevant because I am just dealing with that function by itself. So this is much, much easier to understand, right? I mean, it takes a somewhat different frame of mind from object-oriented programming, but it ultimately is a lot easier to understand because there's no magic state to deal with. It's also incredibly easier to test. Now, the reason it's easier to write tests against this is because you know what the correct answer is for any given input, right? And it doesn't matter what, you don't have to deal with that, well, in the real world, this was not going to be the first call to this function. This is going to be the 75th call, and the 75th time it behaves differently, because no, pure function doesn't do that. It gives you the same response regardless of whether this is the first time you called it or the 75th. So it's much, much easier to test. And finally, it's actually very easy to build more complex behavior through composition, right? So effectively, once you have a bunch of functions, what you can do is you chain them. You say, we're going to call this function and pass the output to the next one and pass the output to the next one. And if at some point the output at the end is not what you want, it actually is very easy to understand what went wrong by actually looking at what happened at every step. So composition becomes your really biggest friend with that approach. Now, a few words about how this actually relates to front end, right? So one of the things that's really attractive to a lot of people about React is React actually applies that logic to UI. So which is to say, React has a render function that is almost like a pure function. It's not quite, but compared to a lot of UI work, it's actually pretty damn close. So which is to say that in React, DOM is not manipulated, it's calculated, right? So basically you say, given the following inputs, calculate the state of DOM for me. Right? And then React takes care of actually updating the real DOM to match with what got calculated by the React function. So now React components do have state, but it's compared to a lot of frameworks, it's actually really limited, and you really cannot modify the state quite as directly as you would with other frameworks. So this is really attractive. Now, I mean, there's a bit of a downside, which is that in React, it requires a little bit of doublethink, right? Which is, I mean, the reason I'm calling it doublethink because, well, you are actually manipulating DOM. Because, I mean, it's nice to think that you are actually generating new DOM every time, but generating new DOM every time would be insanely non-performant. So instead, what React, of course, does is that it basically takes the DOM that's generated by your render function, and it looks at the actual DOM that it has, and it tries to figure out the differences. And in the good case, you don't need to worry about it. But in the bad case, you kind of do. And the moment you start running into a situation where you have to worry about it, it gets a little bit more complicated. So in particular, usually it works really well if your whole application follows that structure. When you start integrating components that actually don't behave that way, let's say you are actually trying to integrate a legacy jQuery component, then it gets a little bit messy. So that's why I'm saying it kind of requires a little bit of doublethink. Now, in contrast, Angular components are, in their essence, stateful. In the sort of normal object-oriented stance, they have, they have a state. And I mean, they have properties, and usually you actually set those properties, and then you could go and assign watchers to those properties. But ultimately, they very much have state. Now, it's important to note, though, that you can actually emulate React's style in Angular, though you have to kind of depart a little bit from the way Angular seemingly naturally wants to do things. But now, so again, this was sort of a bit of a detour about the UI, but what about the data part, the data layers of your application? So what does it mean to actually sort of work in a more stateful way there? So let's talk a little bit about how does state become so painful, right? So you have your typical application where, so you have a component and you have a model, right? So, and this is like wonderful, it's your classic MVC, you've got a component, you've got a model, the component interacts with the model, changes the model informs the component about something. Except for then you have another component, and then you have another component, and then you have another component, and then you have another model, and you have another model, and you have another model, and then everything starts talking to each other, right? And that's where it becomes a mess, because you actually never really know what exactly is the state of anything, and when you actually are going to be modifying, so if your component is going to modify some model, will the other components that have actually gotten that state of this model a few milliseconds ago, will they know that it changed? So you could sort of start doing this in Angular with watchers and things like that, but it sort of soon becomes a mess. We're not even done yet. So now, what's the alternative? I mean, the alternative is unidirectional data flow with Flux. So let me say a few words about Flux before I move on to what I think is an even more exciting approach. So with Flux, you have your components. In this case, it's 2, but it would work. This scales really nicely for any number. And when your component emits an action. So this is the only way that your component ever informs the rest of the application that anything happened. Right? This is really important. This is absolutely the only way it does it. Now, this action goes to, and this is a bit of a simplification. I'll make it slightly more complicated in a second. So this action goes to a dispatcher, which is basically a system that's collects all of the events and then redistributes them to whoever subscribed to any particular kind of event. You then have a concept of a store, and a store is like a model, but it's different in the sense that it only subscribes to actions coming from the dispatcher, and then when it changes the state internally, it goes and it notifies whoever subscribed to it. So in this case, we'll have two components subscribing to the store. So what we get out of this is that the two components will always be synchronized. So if some data changed, it will always be synchronized because the components can't just go ahead and modify the store directly. They only have to go through this somewhat constrained method of doing that. Now, in practice, this is all wonderful, and this becomes just about as simple until you have to do things that are asynchronous, like, for instance, HTTP requests. So when you do that, it does need to become slightly more complicated. And because of that, in reality, usually your components don't literally post actions as objects or as records. And instead, what they do is they invoke in order to trigger something, your component will invoke a function that's called an action creator. And the way this works is that, so an action creator is a function, and that function will go ahead and actually make calls to API, whatnot, and then based on responses of that, it will go ahead and actually post actions. So it will post an action along the lines of, we've asked for data, but we haven't gotten anything yet. It will post another action when the data arrives. If it arrives, it will post yet another action if your request failed, and so on. Now, beyond that, we actually proceed in the same way, where so now action creators issue actions, but possibly not at the same time. Your dispatcher redistributes them, and you have your store subscribing to actions, and then forwarding the results to all of the components. So this approach has a few advantages. One of them is that also a lot of your logic suddenly becomes synchronous. Now, in order to implement something like that, you actually need to work with data streams, right? Because ultimately, what your components will now be, what your stores are going to be now emitting would be streams of events. So you need ways of working with them. Now, there's some great libraries for this. I mean, one that we like for that is RxJS. With RxJS, what you do is you create a stream, and then you start pushing events to that stream, which is my stream on next, and then you share the stream with other subscribers. So for instance, your store can expose the stream to all of the components, and they can go ahead and actually subscribe to that stream by basically associating a handler for the situation when the data has changed. And in this case, your components now are still, and stores are still stateful, right? So let's not kid ourselves there. We haven't actually got rid of state, but the inputs to that state are now a lot better controlled, so we gain a little bit of sanity. Oh, and then finally, one big benefit you get at this point is stream operations. So you can actually, so libraries like RxJS, they give you a lot of great options for merging streams, debouncing streams. So your component could say, I don't want to react every time the data changes in the store. I want to react only at most once per second or something like that. So you can actually start doing those operations. Or your components can filter streams, right? So they could say, I understand that there is constant change in this store, but I only care when a particular thing has changed. Now, when you take this approach, you're actually quickly going to run into one big problem. And that is a problem that I'm going to call misbehaving subscribers. So what happens is that every subscriber gets a reference. So when you emit objects, every subscriber gets reference to that object, right? And while you could sort of implore them to not make modifications to it, they still can do that, right? So and what happens if your subscriber starts actually making modifications to it, right? So suddenly this affects everyone else, and you're back to the mess that we were trying to avoid, where you have no idea who has changed what state. So the solution for here is immutables. Now, immutables come in different flavors, which I think sometimes ends up being very confusing. But I mean, ultimately, immutable data structures of all sorts are data structures that can store data without introducing state by virtue of not being modifiable. So the most trivial way of trying to do that would be to use object.freeze, where you try to freeze an object, but this is very shallow, so this really is not going to give you a lot of mileage. If you are looking to use something along the lines of object.freeze, what you probably actually want is a library called Seamless Immutable. What that library does is that it mimics it creates data structures that mimic JavaScript arrays and objects, but they're actually frozen all the way down. So you really just cannot modify them. So at this point, if you actually use Seamless Immutable to send frozen objects through your streams, then you know that even though all the different subscribers got a copy of the same object, none of them is going to actually modify, and so you can actually enforce that constraint. Now, but what happens if you actually do want to modify your data? Now, at this point, you're like, wait, got to decide. I mean, do we want to modify it, or do we want to not modify it? Well, I mean, what we really want is we want to take the data that we've got, and we want to actually derive something else from it, but we want to do it in such a way that it actually doesn't affect anyone else who didn't subscribe to be part of that mess. So what we want is the concept of derived immutables, where we can take an immutable object and derive something else from it in a way that the initial object is not affected. So whoever has reference to the initial object is going to have there's going to be no implications for them. So you will derive effectively new ones, right? So now Immutable.js, so if that's what you want to do, then Immutable.js is the library to use that, right? to use. So it's a library that basically allows you to efficiently create a frozen object that is unmodifiable directly, but from which variations can be derived very effectively. So in this case, for instance, if data is an Immutable.js object that we will, and we want to actually set the field, so we want data.foo.bar.baz to be 42, then we will use setIn function, and this will give us a new object, which will be just like data, but will now have a different field for foo.bar.baz. The important thing here is, however, is that the actual initial whoever has the reference to the initial data object, that object will not be modified. So and this is really, like the immutables are really a key building block for stateless architecture, and I just want to really highlight that because without understanding mutables, what I'm going to be speaking about next is not going to actually make a lot of sense. Now, so we can get with Flux, we can actually go a long way towards, so using Flux in combination with stateless, with immutable object like Immutable along the lines of Immutable.js, we can go a long way towards taming complexity, but it turns out we can actually get quite a bit more stateless. And using a library called Redux. Now, this is a library that isn't really widely known, it seems, or at least it's not nearly as widely known as it really should be. But I think it's the best thing since sliced bread. So the key concept of Redux, I mean, you can think of Redux as Flux, kind of like what I talked about before, but taken to its logical conclusion, right? It's really taking the best idea of Flux and saying, let's actually just take that all the way. So the key idea of Redux is the idea of reducing actions. So let me just, how does it, like a standard basic reduce function, I mean, a lot of you probably use it, hopefully. I find that out of the sort of basic functional methods in JavaScript, reduce probably gets least love. I mean, a lot of people know how to use map. A lot of people know how to use filter, and that's where a lot of people stop. And if you love map and you love filter, you probably should actually learn reduce also. So what reduce does is that it takes two arguments. It takes a function that modifies, it takes as a first argument a function that with two arguments, where the first one is a value, and this value is going to be repeatedly different items of the array on which we call reduce, and then the state, and then then it outputs the new value of the state. So for instance, if we want to sum up the function, we would use, so this would be a basic use of reduce to add up the numbers. So what we are saying is that the sum of two of those five numbers could be calculated by starting with 0, and this second argument is the initial value, and for every number taking the item of the array that we're at now plus the current state and returning the sum of the current value and the item. So in this case, we'll say the first time we'll call it with 1, 0, and we'll return 1. Our state is going to be 1. The second time we're going to call it with 2 for value and 1 for state. We're going to return 3. The third time we're going to call it with 3 for value and 3 for state, and so on. And this is how we actually add up the numbers, right? So this is basic use of reduce. Now, in a Redux app, you can think of, so the state is basically a reduction over a history of actions. So the idea is that if you think of your history of actions as an array, then what we're going to do is we're going to provide methods that will allow us to calculate the current state by going through that history, and actually every handler taking every action, modifying our state into a new one in an immutable manner. So here is an example of how a reducer looks like in React, and this is combined with the Immutable JS that I've shown a little bit earlier. So here we are going to, it's a simple application that basically processes nodes. Think of like, Evernote, along the lines of Evernote. And what we want is when we want to update a node content, what we're going to do, update node content is an action that at some point flies by. And what we're going to do is we're going to provide a reducer for that action. And the way we're going to provide this reducer is we're going to say, it's a function that takes the previous state and the action and gives us the new state where the corresponding content of the corresponding node has been set to the new state, right? To the new content. And then alternatively, for some other action, we could just do nothing by effectively simply returning the previous state. Now, again, the great thing about this is that this is purely immutable, so we can't actually just go and reach into the state and modify whatever we want in it, and we instead, every time we return a new state. So what does it give us? Well, a few things. So first, and this is one of the big items, that is each reducer is a pure function, right? So each reducer, the effect of that reducer is determined just by two arguments that it gets passed in, the state and the action. So given the state and given the action, you know exactly what that reducer is supposed to return, what kind of state it's supposed to return. So what this means, of course, is that suddenly it becomes a lot easier to write tests. It becomes a lot easier to understand any given reducer and so on. The second one is that every reducer is actually independent of each other. I mean, it takes a state and it returns a new state. The third item here, and this is kind of almost surreal, but out of the box, you get the ability to roll back your changes, right? And this is just tremendous for debugging. So let me actually do a very quick demo of how this works. And so here is a very simple application. And the panel on the back is actually part of Redux tools. And what I'm going to do is I'm going to create so there's an add node button. Add node button, as you can imagine, so there's not a handler for so there's not inside of an add node a function that goes and starts modifying data. No, add node issues an action called add node, right? So when that action is created, then a reducer along the lines of what I just showed you is applied, and we get a new node, right? And then if we do this, and here we can see on the side, again, this panel is just part of the Redux development tools. It shows us that this action has flown by. And so we can now go ahead and create another one. And we can see that, again, a different action happened. We can filter. No, let me not do this. And now here's what's exciting about this. So we had those two actions. So we started with the initial state. We saw two actions. We can go ahead and actually trivially undo them. Now, the reason we can do that is because our current state is always a reduction over the history of state. So as long as we store the history of actions, we can go back and actually undo them, right? Now, on the flip, and then we can actually redo them out of order, right? So I could say, let's actually pretend that I didn't create the first action. I didn't create the first node. I only created the second node. And then just from the perspective of debug tools, one of the things that you could do is you could actually commit, and you could say, OK, this is what's going to be now my base state. And I can go ahead and interact with my application. And then at some point, I could revert and go back to where I started. And I hope you can just imagine how much it simplifies your debugging. Almost to a point where you're still thinking if you should still be writing unit tests. But you should, because writing unit tests is also a lot easier right now that you're dealing with pure functions. So this is actually really quite tremendous. Now, and the other exciting thing is that your reducers can now actually stay synchronous, right? So a lot of your asynchronous code is now gone because when you are dealing with business logic, there isn't like this sort of classic .then. An action came, and you've got your state, and you've got your action. You return a new state. You perform that calculation synchronously. And it makes, again, writing tests against those reducers. So I mean, bulk of your code now is going to go into reducers, and that code becomes much, much easier to test. So now, there is a catch, as always, that at some point in your application, you need to actually deal with asynchronicity somewhere. And the approach here is similar to what you would do with Flux. You would deal with asynchronous actions through action creators. So let me show you a quick example, because this is, I mean, everything I've shown up to now is really simple, but this piece is slightly more complicated. So let me dive in slightly more detail here. So your process is going to be the following. You're going to call an action creator, which is a function, to initiate a request. So this is when, like, say, for instance, something happens and you actually want to go and get new data. Your action creator, it will immediately emit, and usually an event, an action that basically lets your application know that that the request was made. Right? Now, you can then assign reducers that actually handle that particular action, and maybe what they do is they actually, so somewhere in your state you have a isSpinner visible, and your reducer will actually go ahead and change the isSpinner visible to true, for instance. Your action creator then actually makes an HTTP request, and then it goes and emits an event, an action, when the results arrive, if they arrive, or when they fail, if they fail. You also, in most cases like that, you would want to push the details of making HTTP requests and all of that stuff into a module, and that's where you probably want to actually draw on everything that you've learned over about promises, because there's going to be some sort of asynchronous code there. But the nice thing is that once the data arrives, from that point on, you can actually start dealing with it synchronously, right? Because from the way you write your reducer just says, well, I've got a state, I've got an action that says some data arrived from the server. I generate a new state that takes it, that accounts for that new information. So the first part of, so if we wanted to actually implement it, our first example, this is just kind of the the preparation. We would want to probably create a function that creates an action for the three. So we'll actually be issuing 3 different actions. We're going to create one for initial. To signify the fact that we've actually made a request, one upon success and one upon failure. So we'll create a little function that basically takes a status and takes data and then generates an action. So in this case, the type of the action is going to always be fetch nodes. And then in the payload, we'll specify the data if we have data, and we'll specify status, which could be requested, received, or failed. And then here's how our code is going to look like for actually handling it, right? So we're going to basically say, we are starting off by, no, this is ES6 code, and if you're not yet using ES6 widely, then I really would recommend doing this. Our fetch nodes action creator basically returns a function that takes a dispatch function as an argument, and this is the function we're going to need to use to actually send out actions. And what we're going to do is we're going to call fetch data, and this is an asynchronous library, effectively in this case, that makes the actual requests. And we're going to first dispatch an action with the type request. We're going to then make a call. In our .then, we're going to dispatch an action that's sending the data, signifying that the data arrived and actually including the data. And we're going to then attach a .catch, which catches the error and dispatches an action for that error, right? Now, the cool thing here is that we're kind of done here with the asynchronous part, right? From this point on, the rest of our processing of this data is going to be synchronous. Our reducers are just going to be, this data arrived while in this state. Here is the new state. So back to React or Angular. Now, I think the first thing that we kind of need to keep in mind is this can actually all be done with both React or Angular, right? And so in particular, Redux has an adapter for React. It has an adapter for Angular. You could use it with either, and I think that really ultimately whether it's React or Angular is probably not your biggest decision. What you're doing on further deeper in your stack is what matters more. Now, Redux aligns, I would say, conceptually with React cleaner. And what I mean by that is that because it comes out of the same line of thought, when you're using Redux and you're using React, then you feel certain unity with the universe, right? Is as opposed to when you actually are, Angular requires you a little bit of a translation, both in terms of there's a small library that basically will convert state changes into changes in your components, but it also requires a little bit of a mental sort of switch. So what I've been finding myself is when I try to do that with Angular, I just find myself a little bit frustrated with Angular. However, my hope is that Angular 2 will actually resolve this, and it's going to be a lot easier to integrate this with Angular 2. Now, Angular does have, I think, one sort of big upside is that it makes it quite a bit easier, I find, to integrate third-party components, right? So because React is really wonderful as long as everything follows that logic of sort of calculating state, but the moment you have a big component that you can just go ahead and destroy and recreate, where you really have to make sure that that component stays on the page, and you have to kind of fiddle suddenly with methods, like with component life state methods in React, then suddenly like the fact that this statelessness was a bit of a lie hits you, and then you have this a bit of a cost. So I'd say that if you're integrating a lot of third-party components, that Angular kind of makes that easier. And finally, I think a big chunk of this today is really kind of a cultural difference. I mean, when it comes to let's say an organization deciding whether they want to invest in React or invest in Angular, I think it's really worth, first of all, to think of, well, which community do you feel more aligned with culturally, and that often may be a bigger consideration. Thank you very much.